Equations are set up to graph in two different ways. This first one is in slope-intercept form because y equals something. Y is by itself. The easiest way to graph this is to go down to -6 on the y-axis and put a dot. So I'm going to click my graphing tool, go down to -6. I'm going to click to put a dot. Then my slope is 3. That means I go up 3 points to the right one and then put my dot. I've graphed the first equation. The second equation is set up to graph using the intercept method, where if we plug in a 0 for x, we get out y, so on the y-axis, y equals 6. And then if I plug in a 0 in for y, I get out x equals 6. So my second dot, I'm going to click at x equals 6. And so that's it. That's the graph. Let me see if I can get to I think there's a second part. It says, what's the solution? The solution of any system of equations is where the two graphs cross. So it looks like they cross at 3 on the x-axis and 3 on the y-axis for mine. It's kind of small. That looks right. You could test that too. If you plug in 3 in for x, 3 in for y, it comes out to be true. If you plug in 3 in for x, 3 in for y, that comes out to be true. So that's our solution. It'd be dependent if you graph both of those lines and they were actually just one line on top of one another. It'd be inconsistent if you graph both of those lines and they were parallel because they would never have a solution. They would never cross.